All right. Hello, people of geometry. This is Mr. Heeren, and I'm wondering how 4.1 went. I hope it went well. I know there are some thoughts that you need to work through. You need to spend some time with, so you can kind of understand what you're doing. Now we're gonna shift to parallelograms. Okay, parallelograms. That's going to be our focus, and parallelograms are very specific. What we call quadrilaterals. Okay, so a quadrilateral, which I mentioned a little bit in the previous video. Quad meaning four, lateral meaning sides. Okay, so a quadrilateral is any shape with four sides. Okay, so this is like anything that has four sides will be a quadrilateral. But a parallelogram is more specific, okay? And there's certain properties that hold true in a parallelogram that we need to discuss and you need to be familiar with. You need to be able to recognize these and use these to kind of help you show that a specific shape might be a parallelogram, okay? So we start here, okay? Start very simple. As the name implies, parallelogram, okay? So what we have here is we have two sets of parallel lines. Okay, so we have two sets of parallel lines. Okay, so an example here, you have AD is parallel to BC, and you have AB is parallel to DC. Okay, so you have two sets of parallel lines. Okay, that's kind of a big idea of a parallelogram. You have two sets of parallel lines. Okay, so that's the big one. Two sets of parallel lines. So opposite sides are parallel. Next one, quadrilateral is parallelogram, then opposite legs are congruent. All right? So that works forwards and backwards. If both pairs of opposite sides of a quadrilateral are congruent, then it's a parallelogram. Okay, so if it's a parallelogram, opposite legs are congruent. If both pairs of opposite legs are congruent, then it's a parallelogram. So it works forward and backward. And that's kind of what we're talking about. So two things, right? Two things, okay? Both pairs of opposite sides okay? Two things, parallel and congruent. So parallel and congruent. So those are the first two. Pretty straightforward, nothing too brain-breaking yet. So both pairs of opposite sides, parallel and congruent. Those are the two big ones, big ideas there. So now we kind of go inside the shape a bit, okay? So first one, opposite angles are congruent. Okay, opposite angles are congruent, then it is a parallelogram. So we're looking for congruence there. And then, much like parallel lines, okay, when we had a transversal way back in Unit 2, okay, remember this was the only situation where it equaled 180. Okay, those two angles together equaled 180. They were called consecutive interior angles. So in a parallelogram, okay, if I take any two consecutive angles, any pair of angles, that are not across from each other, they should be supplementary. Okay, and remember supplementary just means that they add up to 180 degrees. Okay, so we've got things for the sides. We've got sides are parallel, congruent. Now we're saying angles. Opposite angles are congruent. Consecutive angles are going to add up to 180. All right, so now we're up to 4 properties so far. Okay, so if we look here, oops. So if we look here, if this is going to be a parallelogram, then you're going to have to say, well, 6x plus 3 is going to have to equal 15. 4x minus 2y is going to have to equal 2. Okay, which isn't too bad, not too brain-breaking. So minus 3, 6x equals 12. Divide by 6, divide by 6, x equals 2. Okay, so we figured out x. All right, so now for this one, I'm going to simply substitute in what I know. So 8 minus 2y equals 2. I'll continue this down here. So 8 minus 2y equals 2. Subtract 8, subtract 8. Negative 2y equals negative 6. So when I divide, that makes it positive. So x would be 2, y would be 3. And I did that based on the fact that the opposite sides have got to be congruent in order to be a parallelogram. Okay, opposite sides have to be congruent. Oops, skipped one. So now here, let's see. Find the values of x and y so that the figure is a parallelogram. So right away what I'm looking at is A and C. They're across from each other. I know in a parallelogram, the opposite angles are congruent. Okay, opposite angles are congruent. So 2y minus 40 is going to be equal to y plus 10. So if I add 40, subtract y, 0, 0, this becomes 50. I do add those. So y will equal 50. Okay, so how do I figure out x? X, here I got to be a little clever. Here I got to think a little bit. Remember, any 2 has to add up to 180. Okay, those two angles have to add up to 180 degrees. It's the only way this becomes a parallelogram. So now that says 4x plus y plus 10 equals 180. Okay, but I know what y is. I know that y is going to be 50. So that makes this 60, subtract 60, subtract 60. So 4x would equal 120. So x will equal 30. There's my answer. There's my answer. Okay, and it's recognizing this step right here, that these two have to add up to 180. That kind of breaks this open for x. Okay. Okay. So the last property that we want to spend a little time with is this. In a parallelogram, the diagonals bisect each other. So what does it mean to bisect? Well, that just means cut in half. That's all that means, cut in half. Okay, so they bisect each other, so they cut each other in half. So this length AP is equal to this length, okay, and this length is equal to this length. Okay, and if they bisect each other, then it's a parallelogram. So logically arguing, it works forwards and backwards. That's kind of what we're looking at. So now we have our 5. We have our 5 properties. So pairs of sides, should say pairs of opposite sides. Okay, they're going to be congruent, and they're going to be parallel. Again, I'm talking opposite sides. Okay, then I've got opposite angles. They're going to be congruent. Then I've got consecutive angles. Okay, they're going to be supplementary. Forgive my handwriting here. I'm in a bit of a hurry. And the last one is that the diagonals bisect And if you're not familiar with bisect, I suggest you get familiar with that word quickly. So we have 1, 2, 3, 4, 5. And those are your 5 properties of a parallelogram. Okay, if something is a parallelogram, all of these are true. Okay, and if you need to prove something is a parallelogram, well, if you can prove one of these things, then it's a parallelogram. So now here, figure out the values of x and y for that to be a parallelogram. So now let's look. Remember, they bisect. Those are the diagonals. They bisect. So negative 4x minus 2 equals negative 3x plus 4. 3y minus 5 equals 2y plus 8. So now it's just, it's an algebra problem. It's something you've done before. It's good practice to keep straight. Okay, so now you're going to get negative 6 equals just x. So x equals negative 6. That's nice that it worked out like that. Negative 2y plus 5 plus 5. Boom, boom. Y equals 13. Bam. There we go. So, nice couple easy 2-step equations and we're home. So now, for this problem, it's not stated very well. We're going to assume that the QRST is a parallelogram. Parallelogram. Okay, so sorry, QRST is a parallelogram. We're going to assume that. Okay, so now let's look. So I see 5x's right here. We're going to assume this is a parallelogram. So 5x will equal 27. Okay, that will not work out cleanly. We will have a fraction, so it will be 5 2/5. Throw that in your calculator. Should get 5.4. Should get 5.4. Let's see, for y indicates this length, y plus 4. 2y minus 5 is that, y plus 4 is that. So we're talking about the diagonals. So those two are going to be equal to each other. So subtract y, add 5, add 5. 0, 0, so y equals 9. There's my answer. There's my answer. Okay, so now if we look at 3z is right here. Okay, that's 3z at this like PST angle. So now when I look, that matches up to this one, PQR. This is almost like saying, if I've got this, well, what kind of angles are, sorry, wrong one. I don't want that one. I want the other one. What kind of angles are these two? Well, they're going to be equal. They're going to be equal. Those are alternate interior angles. Okay, so that makes that one here and that one here. So 3z equals 33. So 3. That's a nice review from unit, I believe that's unit 2. So being able to recognize that is important. Okay, so now let's look. So final piece here. So if you can show, okay, this is kind of combining a couple properties. If you have one pair of sides, parallel and congruent, then the quadrilateral is a parallelogram. Okay, so if you can show one pair is both parallel and congruent, then the quadrilateral is a parallelogram. So I am I'm just concerning myself with AB and DC, okay, and I'm just showing boom, boom, parallel, parallel. And this seems to be pretty straightforward. If how do I know this is going to work? Well, if I consider that if these are not parallel, if these are parallel, then they're always going to be an equidistant apart, right? That's like definition of parallel. They're always going to be equidistant apart. Well, if I say these two are the same length and these two are the same length, then by default, the only way is if those two are also parallel and congruent. So it's absolutely has to be a parallelogram. And if you didn't 100% follow that, that's fine. I'm not asking you to prove why it works or try to, kind of decipher why that's a true statement. But I just want you to realize that if you can recognize one pair, congruent and parallel, then you're good. So based on our properties, do we have enough? Do we have enough to say yes? Well, let's see. For number 5, this is 12, this is 12, this is 5, this is 5. So I would say yes. Okay? You get two pairs of opposite sides are congruent. For number 6, you've got these two are 85, okay? And you've got these two are equal. I'm going to say I don't believe so. I don't believe so, okay? Because, hold on one moment. You know what? Nope, I'm going to stay with no, okay? Because you don't have either one completely shown, okay? You don't know what this angle is and what this angle is, okay? And you don't know what this side or this side is. So no, that's not enough information. Even though it looks like it. This looks good, but not enough information. Not enough info, though, okay? You don't tell me enough about any one of the angles. For number 7, yes, okay, that's that property we just talked about. One pair, both parallel and congruent. And so, yes. And number 4, or number 8, all you know is these two sides are equal. And that's a no, because you know what? If I do this, both those sides are still equal, and that is absolutely not a parallelogram. So that one's going to be a no. That one's going to be a no. Okay, so now this is a little bit of coordinate geometry. So we kind of look at a quadrilateral, and if you wanted to, you could kind of sketch this out, but you do this by looking at slopes, okay? So, and we look at this by, do we have two sets of congruent slopes? Okay, so they gave us a slope formula. So QR, okay, so QR, so if I go -1, 3, R is going to be 3, 1. So that would be 1 minus 3, 3 minus -1. So it'll be -2 over 4. So that simplifies to 1/2. Okay. So then ST. Okay. So ST. So that'll be -1, -1 minus -3 over -2 minus 2. Yep, so that would be, let's see, -1 minus -3 makes that positive, so that one's that, so that becomes -1/2. Okay, well, so far those two match up, which is good. Okay, so those two lines would be parallel. So now we need these bottom two to also be parallel in order for this to work. So if I look at RS would be -3 minus 1 over 2 minus 3. So let's say -4 over -1, so that just becomes +4. Okay, so now I need this last one to match. TQ, so if I go -1 minus 3, and that would be -2 minus a -1. Okay, so that will give me -4 over -1, which is 4. Okay, so 4 and 4, -1/2, -1/2. I'm going to say yes. Okay? Yes, you have 2 sets of parallel lines. Okay, 2 sets of parallel lines. So and so you have 2 sets of parallel lines, so 2 sets of parallel sides. So I'm going to say yes by that. Okay. So now you go on to 4.2 quizzes. Make sure you get 100%. And I look forward to answering your questions.